Hello everyone, my name is Rusagiriza Idrissa. I use reg number of 21 RP 02599 and I'm the member of group 3 in IPRC G class IT year 3B. Yes, and as you see, this is our group, all members, and we are here for presenting for you our IoT project, which is called smart car parking system using Arduino, and that is our project title. And the aim of this project, as you understand, it is for smart parking system where there is ability in our system to know that there is an object coming into our parking system. That object is car, say in project name, and so that our parking may allow the car to enter for parking or not allow based on what we have inside our parking, whether the parking space is full or there is still other places for parking. And as I was telling you that this is, we use Thinkercad for this prototype. It is for showing you how it works using this Thinkercad. Without taking much time, I have a big group and everyone has contributed in this development of this system. So every one of us, as you see, has their own thing or some information to tell you about this project, so you may have clear understanding about our project. Yes, once again, it's a smart car parking system using Arduino. That is why I'm going to allow my group members to come and start step by step, show us how this smart parking system it will works. Yes, so let me welcome my group members, another group member, to tell you more about this. Thank you.
I'm here to continue. My name is Karine Chizere. My reg number 21 RP 03767. First one, we have 5 sensors: LDC motor, actuator servo motor, jumper wire, and breadboard. First sensor, it helps to open gate between sense vehicle. The second one, it helps us to leave vehicle. The third one and fourth, it helps us to sensing vehicle, parking, sorted vehicle, and this monitor, it helps to display microcontroller process data, and actuator servo motor is used to open and close gate automatic, and microcontroller it helps to use process data. Jumper wire is used to connect circuit breadboard. Other member, I will come to continue.
Thank you. Morning once again, member. Here we have my names are Eric Wineza and reg number 21 RP 0300. Thank you. Here we have party of coding. Let's tell you how it works. From here we have library. We have different libraries, but here in our project we choose two libraries to use. Here we have include server.h and we have include liquid crystal.h. Here we have a declaration of RCD display, R2, R1, 5, 4, 3, and 2. Here we have another declaration 10, 9, and 8, 7, and 13. This is the pin that help us to use. Here we have server, my server. Here we have another declaration of distance between threshold, 10 meter per 1. Here we have another declaration, parking available. This is the position we have in our project. We have 3 positions. This is declaration of when no car we have in our position, we start from 0. Here we have a setup function. This function have declaration of RCD begin 216 and 2. Here we have rcd.set cursor 0.00. Here we have serial.build 9600 my server.attach 6 my server.write 0. Here we have another declaration of long lead distance. Here we have a declaration of trigger pin and echo pin. This is a pin mode. We have trigger pin as output. And here we have a digital write trigger low. When trigger pin to be low, that flows 2 microseconds. Here we have a digital writer trigger pin as high. We have delay time microsecond 10. Digital write trigger pin low. When trigger pin is low, here we have pin low echo pin as input. If this echo pin is input, then return pass in echo pin high. Here we have another function called loop. This loop we have a declaration from 5 sensors: D1, D2, D3, D4, and D5. D means distance. When we have a distance from D1 equal like this, star lead distance T1. Here we have another distance 2 equal this star lead distance T2. Here we have distance 3 equal like this star lead distance T3, and D4 equal this star lead distance T4. Here we have another distance 5 equal this star lead distance T5. Let's get all sensor reading from different environment. Here we have a serial.print distance 1 equal this string and centimeter. Here we have another distance 2 equal like this plus centimeter, and we have distance 3 and equal this, and we have distance 4 and distance 5. Here we have a display or sensor distance on a serial monitor. let's we allow another group member to help on to show what the next step about the coding. Thank you.
Okay, thank you for our group member. My name is Hirgo NSA. My leg number is 21 LP 035 03065. Okay, I'm continue to explain the condition that can be used in this project. Our last group member can explain the declaration that can be used, like the declaration of the distance or the ultrasonic sensor distance. Okay, I'm continue to show you what the sum condition can be used. Okay, the first condition can be if the barrier state means the gate, it is the gate. It is this the servo motor that can help to open or to close the gate. If the barrier gate equals 0, and you have the instead if that can be contained in the other if the distance 4 or d4, it is the fourth sensor, this one. This fourth sensor, it is the parking. If the parking 4 or d4 are greater than 2 are less than 100 and the d5 or parking 5 are less than or equal to 100, the parking available is equal to 0. And the parking available can be decremented. Okay, and the barrier state can be decremented. Then here we have the my servo.right equal 19. Then you have the second if or second condition, if d4 or the fourth parking can be greater than the 100 and d5, the parking available can it be 3, means the parking available is 3 if the from d4 and d5 can be occupied, the parking 3 does not be occupied. And then on this stage, the next step, it is to increment the available of space, or to increment the space of the parking that can be have. And you have the else if barrier state equal 2 minus 1 means what? Means the gate can be opened and the parking, the 2 or 1 parking can be occupied on this condition, and the next one means 2 parking can be occupied. And then we have the other condition that can help. Then let's continue to see how can be display the output. Here we have the LCD display, means it is the function lcd.setCursor 00. Then if d1 means the distance 1, which is the first sensor, can be rent to enter, and d2 means help to enter, then there is no space left, means what? If the sensor 1 that can help to enter the vehicle or the car can be open, then here the parking 1, parking 2, and the parking 3 can be occupied, means what? The parking does not be available, the all parking can be used. So let's continue. If the parking 1 can be used, the output can be implemented, the 2 and the 3 are available. If 1, 2, and 3 are occupied, means there is no available parking. If 3 and 2 are occupied, means 1 are available and the other 2 are not available. Okay. This part can help to make sure the available parking and the other are be used and the available that can have. So the other part it's to show you the circuit. This circuit that can be used. We have the 5 sensor that can be connected into the breadboard using the jumper wire and the microcontroller or the arduino and the displayer. Here the sensor can take the information, meaning we know the sensor, the functionality of sensor can collect the information from the environment or information that surround the sensor. This sensor can take the information, means what? If the intra sensor, this sensor that can help to enter, if can capture the information, they are the vehicle that can be around on this gate. The information can be transmitted into this Arduino or microcontroller. Then microcontroller can take those conditions and send to this server to open. After open, the car can come on this sensor to take one of them. Parking can be used. If take one, the display can show me which parking can be left and the parking that can be used. So these are the circuit that can be used and we can show the commands or conditions that can be used. So let's say our colleagues to continue and show how can be use this simulation. Thanks.
ahubwo kano kitwa ngo iki hagati kano hello my name is Denifra and my reg number is 21 RP 03124. I'm going to continue where my colleague stopped, and the previous session they was told you about. For the first one, we told you about the introduction of our project. Mr. Idris and Miss Karin, she told you about all components we have used. And Ines and Eric, they told you how this working about the codes or commands from 1 to 1. And I'm going to continue and I'm going to show you how this working, to simulate how this is working. For the first, here we have two sensor which is called ultrasonic. This one, the first one is help us to open or to enter the object in our parking. So we can say that as like okay, this ultrasonic help us to allow the car to enter into the parking, and this allow to open as this one. Now this is servo motor which help us to, it is act like the gate which help us to open or close the gate. So let us simulate and see how it is working. After simulate, as you see here on the screen, we have by default the display that space left 3, which means that here we have 3 space which is not occupied. And let us try to enter to say that let us to enter some a car, and then you see if one space will be occupied and the other 2 remain is not occupied. Here we have this one. As you see,
if we try to open, as you see here, the gate will be opened automatically. And then if we try to park the car into the parking, let us use this one. Like this, which means that here, as you see here in the space, it show you how the car is enter in the parking. As you see here, we see it lift to space which is not occupied because we have already entered one car. And then if we try to enter another car, here in the screen it will bring it remain one space because we have 3 spaces, we have 3 park, and then 2 already was occupied, and which means that it remain one only. And then if we try to enter another car at the last space, here it will display on this screen the message which say that space is no, which means that there is no space. So in order to open, okay, here as I was told you, I'm going to show what the message will bring on the screen if the car is going outside from the park. So let us try to take one car and bring it outside from the park, like this. As you see here on the screen, it will show you that there is space which is remain because we are already taking the one car from the park. And then in order to show you very clear, here we have another sensor which will help us to allow the car to enter outside from the park. Here we have this will help us to allow the car to get outside from the park. Let me show you. And after we take the object near from the gate, as you see here, the gate will be opened automatically. So thank you very much. This is my presentation. Let me call Divina to explain more about this. Thank you.
Thank you. My name is Moza Divine. My leg number is 21 RP 00602. And I'm here to conclude what my colleagues have been talking about before. And as conclusion, I can conclude saying that automatic car parking system is needed in our everyday life because it could help some companies to save money. They pay. It will help some companies to save money. They pay security guards to secure their guards, where those security guards usually sleep on duties or leave their duties. Our automatic car parking system could help those companies to save money and monitor their all activities being done on their gates without any human touch or any human involved. And also our automatic car parking could help some users to save time where they usually go search for parks and don't find it. It could help them to save time and leave their homes, know exactly where they're going to park, and help them to save also money due to automatic life of our project is going to provide them. And also our project could help our everyday life due to automated life where everything will be automatically without a need of anyone to ask for permission to enter or go out. So our automatic car parking will help in our everyday life to easy our life, our everyday life. Thank you. That was our conclusion and our system.
Perfect.